প্রিভিয়াস ক্লাসে আমরা ম্যাট্রিক্সের এডিশন সাবট্রাকশন পর্যন্ত বলেছিলাম। আজকে যে ক্লাস, আজকে সে ডিসকাস হবে ডিফারেন্ট টাইপস অফ ম্যাট্রিক্স and their properties. First of all, we consider a matrix of the form A is equal to A I J M by N. Therefore, the order of the matrix is M by N, and A is the element in the ith row and jth column. The value of I varies from 1, 2, 3, 4 up to M, and J is equal to 1, 2, 3, 4 up to N. Here, three cases may arise, তিন ধরনের হতে পারে। That is number 1, M not equal to N, number of row not equal to the number of column. Next step, number of row greater than number of column, and third step, that may be number of row is less than number of column. Three cases may arise. Number of row is equal to not equal to number of column, number of row greater than number of column, and number of row less than number of column, and number 4, number of row is equal to number of column. Okay. Now take an example. A is equal to, we know that row A1, first row, first column, first row, second column, first row, third column, and such, first row M, first row N column. Therefore, row that is indicate row, and first, second row, first column, second row, second column, second row, third column, and second row N column. Third row, first column, third row, third column, third row, second column, sorry, third row, third column, and such, third row N column, and M row, first column, M row, second column, M row, third column, M row, N column. We have already discussed that these are the elements of the matrix A11, that is first row, first column. If we consider this element, that is second row, third column. If we consider this element, that is mth row, N column, and this mth row, second column, mth row, and such. Now, first of all, rectangular matrix. বাংলায় আমরা বলি আয়তাকার ম্যাট্রিক্স, আয়তাকার ম্যাট্রিক্স বা rectangular matrix. If number of row not equal to number of column, that is called rectangular matrix. If number of row and number of column be same, that is M is equal to N, that is called square matrix. First of all, give two examples. That is rectangular matrix. Let us now consider X be a matrix of the form X, Y, Z, W, P, Q. This is the order of the matrix 2 by 3. Number of row ফার্স্ট রো, সেকেন্ড রো, ফার্স্ট রো, সেকেন্ড রো, ফার্স্ট রো, দুটো রো, দুটো column C1, C2, C3, number of rows. Whatever the matrix is to be the number of row, not equal to the number of column. This type of matrix is called rectangular matrix. X is equal to 1, 2, 3, 4, 5, 6. This is also a matrix of the order R1, R2, R3, 3 by C1, 3 by 2. Now, number of row not equal to number of column. Therefore, this is also rectangular matrix. Is the number of row is equal to number of column, then it is called square matrix. It is a matrix of the form. It is of the matrix whose elements are x, y, and w, p. Order of the form two row and two column 2 by 2, and similarly 1, 2, and 3, 4. This is also the matrix of the form 2 by 2. This is called square matrix. Now last we discuss the diagonal matrix. Diagonal matrix. If all the elements are 0 except diagonal, suppose x, y, z, p, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. This is the matrix of the order 4 by 4. 4 by 4. Number of row is the number of column. Square matrix said if the all elements are 0 of a square matrix A except diagonal term of the matrix, that is called diagonal matrix. বাংলায় বলছে diagonal matrix. এটাকে বলছি diagonal matrix. এটাকে বলছে diagonal matrix. Okay, এটাকে বলছে diagonal matrix. Give me an example. B is equal to let us have consider square matrix B 1, 0, 2, 3, 0, 3, 4, 0, 0, 6. This is a square matrix whose diagonal term are 1, 3, 6, and others are 0. Therefore, it is a diagonal matrix. That is null matrix. If all the elements of a square matrix are 0, all the elements of the matrix are 0, that is a null matrix of the order 3 by 3. Now B1 is a matrix of the form 0, 0, 0, 0, 0, 0. It is also a matrix of the whose all elements are 0 of the form C1, C2, R1, R2, R3, 3 by 2. Therefore, this is a matrix which is known as null matrix. A square matrix whose diagonal element are unit 1, 1, 1. Others are 0. Diagonal matrix. আগে কি হয়েছিল, ডায়াগোনাল এলিমেন্ট গুলো যদি থাকে বাকিগুলো 0 হয় সেটা হলো ডায়াগোনাল ম্যাট্রিক্স। কোন একটা স্কয়ার ম্যাট্রিক্সের যদি ডায়াগোনাল গুলো 1 হয়ে যায়, ইউনিট হয়ে যায়, দ্যাট ইজ কল্ড ইউনিট ম্যাট্রিক্স। একক ম্যাট্রিক্স বলা হয়। I 3 by 3 1, 0, 0, 0, 1, 0, 0, 0, 1. That is called unit matrix. Okay, next again I will discuss the row matrix. matrix containing matrix of the form is equal to x, y, z, p, q. This is number of row 1, number of column 1, 2, 3, 4, 5, 1 by 5. This is a matrix of the form x, y, z, p, q, and order of the matrix is 4 by 5. Elements along the row only. That is called row matrix. If the matrix of the form x, y, z, p, q, r, s, this is the matrix of the order 1, C1, C2, C1, R1, R2, R3, R4, order 1, 2, 3, 4, 5, 6, 7, 7 row, column 1, only 1. This is the matrix of the order 7 by 1. That is called column matrix, C-L-U-M-N, column matrix. And this is called row matrix. This is called row matrix. Next. Now, another properties of the matrix. Row matrix, row matrix, trace of the matrix, trace of a matrix. Trace means, let now consider a matrix of the form A11, A12, A13, dot, 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 dot. Trace of a matrix. Trace of a matrix কোনটা বলছি? Trace of a matrix. এটা স্কয়ার ম্যাট্রিক্সের স্কয়ার ম্যাট্রিক্স হতে হবে, মাস্ট বি দ্যাট বি এ স্কয়ার ম্যাট্রিক্স A1 A14 A2 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 is third row, first column, third row, second column, third row, third column, third row, fourth column, next line A4, fourth row, first column, fourth row, second column, fourth row, third column, and fourth row, fourth column. The order of the matrix 4 by 4. Now trace of the matrix will be diagonal term summation sum. That is diagonal term A11 plus A22, A third row, third column, and fourth row, fourth column. Sum of the elements in the diagonal position, that is called the trace of the matrix. An example, trace of a matrix. Let us now consider a matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 2, minus 1, 1, 1, 2, 1. Now, trace of the matrix is equal to 1 plus 6 plus 2 plus 1. 1 plus 6 plus 2 plus 1. That is equal to trace of the matrix is 10. Trace, that is called the trace of the matrix. Understand? Next, give an example. Trace of the matrix, I have already. Trace of the matrix. Null matrix. If the all elements of a matrix square matrix are 0, all the elements are 0, that is called null matrix. Null matrix যদি বলি আমরা O, null matrix, that is equal to all elements are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That is called the null matrix. Null matrix. Okay, that is called the null matrix. I have already discussed the different types of matrix. Scalar matrix. If the diagonal element of a square matrix, diagonal elements are equal, then that is a square matrix. A square matrix A 0 0 a 0 0 0 0 a. All the diagonal terms are equal. Scalar matrix 5 5 5 होते पारे, that may be. Now unit matrix, we have already discussed unit matrix 1, unit matrix 1 0 0 0 1 0 0 0 1. Diagonal elements are equal but unit. Therefore unit matrix is also a scalar matrix, but scalar matrix is not an unit matrix. Okay, now next, I have already discussed the addition and subtraction of matrix. Today if we add a matrix with a null matrix, suppose let us now consider a matrix. Let us now consider a matrix. Let us now consider a matrix A is equal to A I J of the order m by n, and I is also the null matrix 0 ij, element 0 I j of the order m by n of the same order. Then a plus I, if we add the matrix A with the null matrix, what will be the result? A I j m by n plus 0 I j of order m by n. Now order of the matrix are same, m by n. So matrix addition is possible, and therefore the matrix after summation will be a I j plus 0 I j. Order will be the m cross n, and this is 0, all elements are 0. Therefore if we add the elements with the aij, that will be the aij. Therefore the a plus I is equal to a will be original. Okay, next, in the next class we discuss the other properties, that is multiplication of two matrices and multiplication of a matrix by scalar, inverse of a matrix, the solution with the help of matrix solution. A system of linear equation can be solved with matrix method. So we have discussed the properties of inverse, how to find out the inverse of a matrix, transpose of a matrix. Last, transpose. Let us now consider a matrix x, y, w, z, p, q. What will be the transpose? If we transpose the matrix A, then we get A transpose of A. Number of row will be in the column, row transfer into column, x, z, w, z, p, q. It is the order of the form 2 by 3, but transpose of the order of the matrix will be 3 by 2, because row change into column and column position change into row. Next class I discuss regarding the inverse property, multiplication rule, and how to solve the linear equation with the help of matrix. Thank you.